Hello. In this presentation, we want to bring to your attention a very controversial topic within the exercise science research community. That topic is wearable devices. This presentation is targeted towards young to middle-aged adults, but especially towards users of such devices, because we simply mean to inform you more about the validity of these devices and how you should be really careful when considering their claims.
Thanks, Robert. So I'll start with the introduction. So within the past decade, smartwatches really have exploded in popularity, and there's a lot of different watches on the market, and with that, a lot of different claims have been made. So like from running watches designed for elite runners to watches designed for like everyday people, they kind of can provide insight into things like heart rate and sleep, VO2 max, stuff like that, and it's a kind of a bit of an issue because a lot of people just blindly trust what their watches tell them about their health. So like people might think that they're healthy because their watch says they have a low resting heart rate or because they get 10,000 steps a day. But that doesn't really give you a further insight into how healthy they actually are. And so, as Robert said, like it's a pretty controversial topic in the kinesiology field today. So today we're going to be diving into three different articles that look into the accuracy of heart rate, the validity of estimating sleep, and the reliability of specifically a Polar V800 watch for estimating vertical jump height. And by diving into these articles, we can kind of determine if the claims that these watch companies make are in fact true or if they're just saying it to say it. And then we can also kind of look into things like conflict of interest, like if Garmin is funding the study, then that's kind of a conflict of interest of stuff like that, or like study design. And yeah, so by looking in these articles, we can see if the claims are true. So for our first article today, I'm going to hand it off to Luca, who is going to dive into the validity of Garmin smartwatches to estimate sleep.
Thank you so much, Jackson, for handing it over. So basically, we're going to be talking about basically the watch predicting your quality of sleep, and basically how relevant that is with their claims. So we looked at this study by Miller. We will cite it below. The goal of this study was basically to test the validity of 6 different smartwatches, and basically we just went with the Garmin because it was the most simplest we wanted to go with. So with this study, 53 men were recruited, and the study used polysomnography to measure actually sleep epochs. And if you don't know what a sleep epoch is, it basically is like a stage of sleep in a finite time that you can that is like determined to be a polygraphic sleep recording. So it's basically just a short period of time where you can predict the sleep. So basically, after doing this study of measuring the 53 men, it found that the Garmin 2454 Forerunner predicted sleep epochs with 98% accuracy and 27% of awake epochs accurately and 89% of all epochs with a kappa value of 0.35. Uh, basically, the the study has some limitations as it was only used for men, and that isn't really indicative of the population of interest. Um, and basically, after the sleep epochs, it was determined with a kappa value, which it could be determined to be fair, as per Miller in the study, fair correlation. Another step they did in the study was to estimate the time of sleep and overestimation of sleep, and that was in turn to be a sleep bias of 45.3 minutes, which is not very great. So basically, this is very good for detecting sleep, but not as good for determining how long individuals are sleeping. And Garmin actually does not actually say a number on their site, but due to the forums online, it is said that these devices are not very accurate. So it was good for this study to actually test this in a way. So this is basically just the results from the study. It does actually have correlation from the line and from the kappa value. And then you have this other table, which just shows the percentages for epochs. And basically what this is saying is just, this is great for use for recreational purposes. but not from physiological data. And you should consult a healthcare professional if you have concerns rather than using a smartwatch on your wrist. And now I'm going to hand it over to Karat about the vertical jump height.
Okay, so the next study we're going to look at tests the reliability and validity of the Polar V800 smartwatch. And pretty much in the study, they tested to see to measure vertical jump height. So it involved two identical testing sessions, 1 week apart from each other, with 22 physically active men who were students who engaged in physical activity at least 3 times a week. So the subjects took part in squat jumps and counter movement jump test using the Polar V800 smartwatch, a high-speed camera, and a force platform. And these measurements were taken from the Polar V800, were then compared to the force platform, which is known as the gold standard when it comes to measuring jump height. And so the results showed that there were similar measurements as the force platform test. And this kind of proves the reliability of this specific smartwatch. And this study had several experts involved in it from the University of Spain and researchers with PhD degrees, which makes it a reliable study. A couple limitations that we saw in the study were that they only tested on men and the sample size was kind of small with only 22 subjects. So since this study only tested the Polar V800 smartwatch, we can only conclude that this specific smartwatch is reliable when testing jump height. Not every other smartwatch can do this. And we can also conclude, there was a p-value given of 0.001, which says that the study is statistically significant. But however, due to some of the weaknesses and limitations of this study, we can't completely blindly follow it, as there are some parts that are not entirely reliable. Now we're going to look into one more study. Pass it on to Robert for that.
Thank you very much. As I've previously stated, in the last couple of years, wearable technologies, especially smartwatches, have surged in popularity, which has also increased the risk of manipulation and naivety among its users. This makes understanding the strengths and especially understanding the limitations of these devices crucial. Many studies have been conducted on this topic, but a particular research caught my eye. In 2020, Dr. Chow and Dr. Yang from the Graduate Institute of Physical Education, Health and Leisure Studies at the National Cheng Kang University conducted a study focusing on assessing the accuracy of heart rate and variability estimation in 2 different smartwatches, one being the Xiaomi Mi Band 2 and the other one being the Garmin VivoSmart smartwatch. In this study, there were 40 participants split evenly between young and older adults, all of whom were in good health. Participants engaged in various sedentary and moderate physical activities while wearing the devices. The researchers used the Polar H7 chest-strapped heart rate monitor as a reference to measure the validity of these fitness trackers. The results were intriguing. Both the Xiaomi Mi Band 2 and the Garmin Vivo smartwatch showed acceptable accuracy in estimating heart rate and variability with error rates below 10%. However, there were some caveats. These devices tend to underestimate the average heart rate, and certain outlier readings were observed, as we can see in this graph. Some limitations of these studies include the researchers did not specify the sexes of the participants, which could impact the results as heart rate can vary between genders. Additionally, the exclusion criteria, such as restrictions against individuals with tattoos or birthmarks, may have influenced the sample's representativeness. So, what can we take away from this research? While wearable technologies offer some level of accuracy in measuring heart rate, there are limitations and inconsistencies that consumers need to be aware of. It is crucial not to rely solely on these devices for health data, and consulting a physician is still your #1 option when it comes to monitoring your health. Final thoughts. As we navigate the world of wearable technology, let's remember to approach these devices with a critical eye. While they can be valuable tools for tracking our health and fitness, they're just a vague reference point. You should use them as recreational uses only, not as a health measurement device that you should not trust it fully. By understanding their strengths and limitations, we can make more informed decisions and how we can use them in our lives.